Hello, students. We're going to do a little bit of a review for the exam. So a few reminders are please upload Experiment 5 to Wolf Den on Wednesday evening. Also, there is an exam to review. This is going to count as your lab grade this week. So please make sure that gets done. I'll talk a little bit more about that in a minute. Your homework is due on Thursday, right? That's going to be, there's 3 different chapters, chapters 13, 14, and 15. Make sure those all get done in Chem 101. And then your exam 2 will be on Chem 101 on Friday. There is a 2-hour time limit, so make sure you set aside 2 hours to do the exam. Doesn't matter what time of day you do it, but it will close at 11:59 p.m. Eastern Standard Time. So please don't wait till 10 p.m. to start the exam, especially in case you have any internet issues. So this exam 2 review worksheet, this is going to be in lieu of lab. So this is what you're going to do for lab. It will be due on Wednesday at 11:55 p.m. You need to upload it to Wolf Den. That will give me time on Thursday to look over them, make sure you did everything right, so that Friday when you take your exam, hopefully you know how to do all of the problems. So please make sure you upload it with work. I need to see the work. I need to see how you did this in order especially to get credit. So it should all be handwritten. I recommend not typing it out because then I can't tell that you actually did it. Please actually handwrite everything. If you want to write it on the computer, that's fine, but not typed. I recommend working with others. So FaceTime your friends, online meetings. We are still doing social distancing, so don't get together as a group, but you can do it all online. That does not mean copying each other's work, so don't just send a picture to somebody else. If they ask for a picture, please call them and say, hey, let's work through this together. Don't just give them the answer. And don't ask for the answer from your friends, guys. Come on. Let's all work together. I highly, highly would love for you guys to meet together and work through these problems. It's going to count as a laboratory grade, so please make sure it does get done and gets done well and turned in on time. So what we've been talking about is chapter 13, we talked about dynamic equilibrium. So that's when the rates of our forward reaction equals the rates of our reverse reaction. That means that we have a reversible reaction, right? We have those double arrows going backwards and forwards. We then talk about our K, our equilibrium constant. Equilibrium constant is our products raised to their coefficients divided by the reactants raised to their coefficients. That would be our K when we are at equilibrium, when the rates are equal. We can also be at different points in time when we're not at equilibrium. We can talk about our Q value. So Q is when we're not at equilibrium, but we can compare it to K to figure out when we will reach equilibrium. So if Q is greater than K, then the reaction will proceed in the reverse direction. If Q is less than K, it's going to go in the forward direction. If Q equals K, then it's going to be at equilibrium. So you would compare your Q to your K value, figure out which way is my reaction going to proceed. Here is an example, right? Your K value is 1.45. So if you had a K value less than 1.45, it needs to proceed to the right in order to make more products. If your Q is greater than 1.45, then it needs to run to the left to make more reactants. So always just compare your Q to your K value to figure out which way your reaction needs to go. We also then in chapter 14 talked about acids and bases. If you have a strong acid or a strong base, you can easily calculate the pH because we know our 6 strong acids, right? Here are the 6. All of these except H2SO4 are monoprotic strong acids, sorry. So our hydrogen ion concentration, if we have 0.1 molar HCl, our hydrogen ion concentration would be 0.1 molar. Then we can just plug it in the equation, pH equals the negative log of the hydrogen ion concentration to figure out the pH. If it was monoprotic. Same thing with bases. All of our hydroxides are strong bases. So we can just go ahead and plug that in. Their POH equals negative log of OH. And we can figure out what the POH is, then do 14 minus the POH gives us the pH. So that is easy enough to calculate the pHs and POHs. When we get to our weak acids and bases, though, that's when we need to use ice charts. So we need to use our K values, our Kas and our Kbs. So remember, there are ionization reactions that they have given us in these charts. There is also a PDF that has all of these tables. So please check out Wolf Den resources for the exam 2 tables. I recommend printing those out, having them in front of you for your exam. So here are some Ka values, Kb values that you can use when you're working with these weak acids or bases. Anytime you see a weak acid or a weak base, that means you need to do an ice chart. Also, if we have a polyprotic acid, so something that has more than one hydrogen ion, it is going to come off different times, right? The first hydrogen will come off, then the second, then the third, if there are three. We can calculate from each of them different concentrations, so please work through some of those problems. Our last chapter, chapter 15, talked about buffers. So buffers resist a change to pH. That buffer, you need to make sure it either has a significant amount of a weak acid with the conjugate base or a weak base with a conjugate acid. You always have to have the conjugate. So an example, H2CO3, that is a weak acid. We take off one of those hydrogens, we get the conjugate base, which is HCO3 minus. So you have to have the conjugate. You have to have that common ion. That CO3 is in both of them. That is its common ion. So you need to make sure there is a common ion for it to be a buffer. You can calculate the pH of a buffer 2 different ways. You can either use the ICE method. ICE works fine. You can do that. Or you can use the Henderson-Hasselbalch. But if you use the Henderson-Hasselbalch, your X has to be small, so you have to do the 5% rule, which would mean that your Ka value has to be pretty small. Remember, the Kas we've usually been doing when they're less than times 10 to the negative fifth, usually they will work with the 5% rule. Also, we talked about titration curves. So there are 3 different types, right? We could do a strong acid with a strong base. At that point in time, in the beginning, if you're starting with an acid and you add a base, all of the base is going to be used up until you reach the equivalence point. So all of your pHs are going to be very acidic in the beginning. Once we reach the equivalence point, we're at a pH of 7. After the equivalence point, all we're adding is that base. All of our acids been used up, so we're going to have basic pHs. If we're doing a weak base with a strong acid on the top right, you will see that we know our weak base is going to give us conjugate acid, so our equivalence point is going to be before 7. It's going to be acidic. We know that at the half equivalence point, our pH equals our pKa. We can also do a weak acid versus a strong base. Our weak acid, it will give us a conjugate base, and so it will be a basic pH at our equivalence point. We can also talk about solubility product constants. That is when we have some salt that we usually say is insoluble, but it's going to dissolve just a little bit. So we can write the solubility product constant by saying the KSP is equal to, right, the ions raised to their coefficients. We can then plug in whatever our concentrations of our ions are and solve for the KSP. Or if we know the KSP, we do have a chart that gives us KSPs out of a whole bunch of different salts. We can solve for the concentrations of our ions in solution. Our last topic is our formation constant. So that is if we were forming a complex ion. Formation constant, it is once again K. So K is products over reactants. This is when we're saying we're not using all of that ion that we're starting with. So that left ion in this case is silver. That silver is not being completely used up to make our complex ion. So we're trying to figure out how much of that silver is left at equilibrium. Once again, there is a chart that goes with that. So please make sure you look at all of the tables that are on Wolf Den. It's one PDF on Wolf Den of exam 2 tables. Look at all of those in order to do the worksheet. So here is your worksheet. As you can see, some of these calculate Kc if you're given a Kp. Here's an ice table. Looks like here's another ice table. Equilibrium concentration. So chapter 15 was pretty much, or 13 was all ice tables. 14, it then talks about hydrogen ions, pH, right? Benzoic acid. So that's a weak acid. So I know I need to use an ice table. Here you go. Here's a pH and percent ionization. Looks like another ice table. Once we get to a mixture of acids, if we have a mixture of acids, you're always going to use the stronger acid and determine the pH from that one. So which is the stronger acid out of these? Ammonia is a base, so you would need to find the OH, POH, and hydroxide concentration to find the pH. And then is each solution going to be acidic, basic, or pH neutral? Remember, you need to look at these. So if we look at NaF, Na came from sodium hydroxide, the fluorine came from HF. So what does that mean about our salt? Down here, chapter 15, use Henderson-Hasselbalch for each of these. Then we get into a buffer. So find the pH of the buffer. If we add an acid, what happens? What's our new pH? If we add a base, what happens? What's our new pH? Here's a titration that wants you to calculate the different pHs. Molar solubility, so that's the KSPs. Determine the molar solubility of each of these. And then here's our last one, which is our finding the concentration of zinc that remains at equilibrium. So that's our complex ion. So we have a nice range of different problems. Please make sure you complete this worksheet for lab on Wednesday. It is due Wednesday night. Thank you very much. And please come to my office hours if you have any questions. Thanks.